score within today. And the first question, what is the range of efficiency in transformer? Why is the range of efficiency in transformer higher than those of other electrical machine? So many of you, I think you copied from net, I think. So anyway, you should know the exact answer. So in university exam, it's not possible to refer your net and all. So if it is objective type question means you cannot switch over to next window and all. Okay. And so what is the exact answer for this question? You should have the word. What is the word? It should have a keyword. So each and every questions will have some keywords. So that should be available in your paper. Then only you will get the mark. Not means it's not possible to get the mark. Okay. So what is the keyword? Are you having any idea? So you are writing some 4 or 5 lines. That and all okay. So what is the keyword it should have in the 2 mark question? So if that keyword is available means you will get 2 mark. So what are the keywords for the first question? தம்பி நீங்களாம் எழுதிட்டீங்கன்னு நினைக்கிறேன். நீங்க வந்து உங்க ஆன்சர் ஸ்கிரிப்டையும் பார்த்துருப்பீங்க, மார்க்ஸையும் பார்த்துருப்பீங்க. 2 மார்க்ஸ் வாங்கணும்லாம் சொல்லலாம். வாட் இஸ் த கீவேர்டு அவைலபிள் இன் தட் கொஸ்டின்? தெரியலன்னா சாட் பாக்ஸ்ல போடு, அன்மியூட் பண்ணி பேசலன்னா. இன்னைக்கு கீவேர்டு நோ ஃப்ரிக்ஷனல் லாஸ். ஓகே, no frictional loss. So efficiency already I told. So if you are having a motor, generator and transformer, what is the range of efficiency? So in the first class itself I have given the value, I think. Okay, so instead of frictional losses we can tell no mechanical loss. The transformer is not having any rotating part, so mechanical losses is absent. Okay, so you will get the maximum efficiency compared to generator and motor. So you should have a mechanical losses, no mechanical losses. In the word engine, you will get 2 mark. Okay. So other than that, if you are writing any story means it's okay, but you should have the keyword. So in the transformer, there is no rotating point, so mechanical loss is 0. Mechanical loss is 0. So the efficiency of the transformer will be high. So the answer you can check with your answer. Okay, state the conditions for parallel operation of transformer. So this also many of you referred to the net and you copied the answer from the net. So that and all we know, because if you are writing own means you will write in points. Points I எழுதிருப்பேன். So நிறைய பேர் points I எழுதல. So you wrote as a paragraph. State the conditions for parallel operation of transformer. So if you type in the net means you will get some answer. So simply you copied that answer from the net. Okay. So you have to write as a point, same phase sequence, same voltage, same frequency, same impedance. Like that you have to write in points. You should not write in a paragraph. So conditions is condition means you should have some points only. So you have to list out the points. So நிறைய பேர் வந்து பேராகிராஃபா எழுதிருக்கேன். நீ வந்து உன்னோட ஆன்சர் பேப்பர் பார்த்தினாலே you can able to know. Okay, you are copied from the net or you wrote ஓனா எழுதிருக்கே அப்படின்றது வந்து you can refer your notes. Okay, and the answer paper பார்த்தினாலே உனக்கு தெரியும். Next, define all day efficiency of the transformer. Okay, so you know the efficiency notation. Efficiency equal to output divided by input. Okay, so here you have to write output for 24 hours divided by input for 24 hours into 100. 100 you have to mention. 100 mention பண்ணவே இல்லை. So it simply put an efficiency equal to so output in 24 hours divided by input in 24 hours, kilowatt hour இல்ல watt hour ஏதோ ஒன்று போட்டுக்கலாம். ஓகேவா? So output in kilowatt 24 hours divided by input in 24 hours into 100. So efficiency will generally calculate in terms of percentage only. Will calculate in terms of percentage. So you have to mention into 100. So அதனால you will get 0.5 mark கம்மியா போட்டிருப்போம். 1.5 தான் போட்டிருப்போம். யூனிட் எழுதலாம் 0.5 குறைச்சிருப்பேன். சரியா? அந்த கீவேர்ட்ஸ் இல்லைன்னா you will get lesser mark. அந்த கீவேர்ட்ஸ் கம்பல்சரி இருக்கணும். ஸோ கீவேர்ட்ஸ் இல்லைன்னா இன்ஸ்ட் ஆஃப் 2 மார்க்ஸ் யூ வில் கெட் 1.5 ஆர் 1. பார்ஷியல் ஆன்சர்னா யூ வில் கெட் லெஸ் தென் 2 மார்க்ஸ். ஸோ இந்த ப்ராப்ளம்ஸ் வந்து மேக்ஸிமம் எல்லாம் போட்டிருக்கீங்க. ஸோ இந்த ப்ராப்ளமோட வேல்யூ வந்து நான் 4th கொஸ்டினோட வேல்யூ. ஸோ நிறைய பேர் 81, யூ ஆர் கெட்டிங் 81 அண்ட் 87. ஸோ 87 இஸ் த கரெக்ட் ஆன்சர். ஓகேவா? ஸோ இஃப் யூ ஆர் கெட்டிங் 81 மீன்ஸ் யூ வில் கெட் 1.5. ஸோ 87 போட்டிருந்தீங்கன்னா யூ வில் கெட் 2 மார்க்ஸ். ஓகேவா? ஸோ நெக்ஸ்ட் இந்த 5th கொஸ்டின், வாட் ஹேப்பன்ஸ் இஃப் டிசி supply is applied to the transformer. So here also you will have some keywords. So if you apply the DC supply, so you will get the keywords saturation or overheating of winding, or more amount of heat is generated. So in the words la irundhuchina da you will get 2 mark. Okay va? So other than that, if you wrote something means so you won't get full mark. You will get some partial mark, but you won't get full mark. Okay, core will get saturated, and next the winding will get overheated. So will have a constant flux. The flux will not vary. So on the words edavadhu irukanum. Okay va? The 2 mark la doubt iruka? So with this answer we will upload the key also. So we will upload the key in the Google Classroom. So you can verify the key also, answer key you can verify. So beyond that, if you get less mark means you can contact me. So and A section and later entry students, if you are having further doubts. So in this 5 questions, are you having any doubt? So this you can refer the answer key also. Okay. So next, as per the part B. So no, okay, no. So as per the part B, derive and explain the equivalent circuit of a single phase transformer. So இது வந்து நான் நிறைய பேருக்கு கொஸ்டினே படிக்கவே இல்லை ஒழுங்கா. Derive and explain the equivalent circuit of a single phase transformer. So we discussed the single phase transformer வந்து நாகராஜ் சார் எடுத்திருப்பாங்க. So single phase transformer ஓட ஈக்குவலன்ட் சர்க்யூட்டை பத்தி தான் பேச சொல்லியிருக்காங்க. ஓகே, கொஸ்டினே அதான். You want to derive, you can have the other words, you can have this question like this step by step procedure to obtain the equivalent circuit of a single phase transformer. You can draw the equivalent circuit and you can give the assumptions list out பண்ணிட்டு, and you can discuss what are the core loss component, what is the primary, what are the parameters in the primary, what are the parameters in the secondary, and you can draw the equivalent circuit. And if you refer the secondary parameters to the primary, so how will you get the equivalent circuit? What is the simplified equivalent circuit? இதெல்லாம் தான் you got to discuss. ஸோ இதுல வந்து ஒரு 2-3 பேர் தான் கரெக்டா இது ஆன்சர் எழுதிருக்கேன். ஓகேவா? 87ல 87 பார்க்கல, அட்லீஸ்ட் 45 ஸ்டூடெண்ட்ஸ்ல ஒரு 2 or 3 ஸ்டூடெண்ட்ஸ் தான் ஈக்குவலன்ட் சர்க்யூட் பத்தி எழுதிருக்கேன். மற்றவங்க எல்லாமே சிங்கிள் ஃபேஸ் டிரான்ஸ்ஃபார்மரோட கன்ஸ்ட்ரக்ஷன் அண்ட் பிரின்சிபல், அது வந்து கொஸ்டின் கேட்கவே இல்லை. ஓகேவா? So here the question is derive and explain the equivalent circuit of a single phase transformer. அவ்வளவுதான் கொஸ்டினே. Okay, we are not asked about the principle of transformer. Transformer principle கேட்கல, ஸோ அதோட கன்ஸ்ட்ரக்ஷன் கேட்கல, அதோட டைப்ஸ் கேட்கல, ஸோ கம்பேரிசன் பிட்வீன் கோர் அண்ட் ஷெல் எதுவுமே கேட்கவே இல்லை. ஸோ ஹியர் we asked what is the question means equivalent. You have to discuss anything related to equivalent circuit. You can have a final equivalent circuit and you can explain. Or you can have a first equivalent circuit, from that you can simplify that circuit and you can obtain the final equivalent circuit. Or you can explain the parameters referred to the primary or parameters referred to the secondary, and you have to write all the equation. Core loss component, what is I naught, what is IC, what is I mu, R naught, X naught, R1, X1, R2, X2, R naught 1, X naught 1, Z naught 1, Z naught 2, R naught 2, X naught 2. So you have to explain these parameters, then only you will get almost 6.5 or 6 mark. And if you discuss anything irrelevant to this question means, if you are explaining about the principle of operation, and then you won't get mark, 1 mark or 0 போறதுக்கு பதிலா 1 மார்க் கொடுத்துருப்போம், அவ்வளவுதான் அந்த கொஸ்டினுக்கு. ஓகே, you can put 0 also if you write the principle of operation. ஸோ நிறைய பேர் கொஸ்டின் புரியலையா எனக்கு தெரியல, ஏன்னா ஆல்மோஸ்ட் 95% ராங்கா தான் இந்த ஆன்சர் எழுதிருக்கேன் இந்த 6-1க்கு. ஸோ இதுல என்ன ப்ராப்ளம்? ஈக்குவலன்ஸ் இருக்குன்னு உங்களுக்கு கொஸ்டினே தெரியலையா? இல்ல சரியா கொஸ்டின் படிக்கிறது கிடையாது. கொஸ்டின் வந்து ஒரு டைம் 2 டைம் படிங்க, படிச்சுட்டு யூ கேன் ப்ரொசீட் வித் த ஆன்சர். ஓகேவா? ஸோ நெக்ஸ்ட் செகண்ட் கொஸ்டின்ஸ் இது எல்லாமே வந்து இது அட்டன் பண்ணியிருக்கேன். அது நீ எப்படி அட்டன் பண்ணு உனக்கு தான் தெரியும். ஓகேவா? ஸோ நெக்ஸ்ட் செவன்த் கொஸ்டின், எக்ஸ்பிளைன் த ஆபரேஷன் ஆஃப் ஏ டிரான்ஸ்ஃபார்மர் வித் நெசசரி வெக்டார் டயக்ராம்ஸ் ஆன் நோ லோட் அண்ட் ஆன் லோட் வித் யூபிஎஃப். ஓகேவா? ஸோ ஹியர் யூ ஹேவ் டு எக்ஸ்பிளைன் த வெக்டார் டயக்ராம்ஸ் ஆஃப் ஏ during no load and load. With load means we have three power factor: unity power factor, lagging and leading. So for no load also you will have a phasor diagram. Okay, phasor or a vector diagram almost same. So you have to explain the vector diagram. No load means what is the relationship between I naught and core loss component and magnetizing loss component, and how you are getting final current. So you will have the phasor diagram. What is the relationship between voltage and EMF? So அதெல்லாம் தான் டிஸ்கஸ் பண்ணோம். You have to draw the phasor diagram for both the cases. So you have to explain how you are getting that phasor diagram. So no load you will get 3.5 mark. On load with UPF you will get 3.5 mark. Okay. And next, so next 7 second subdivision. So இது நிறைய பேர் சால்வ் பண்ணிருக்கேன். Here you have to identify the watt meter. We have 4 watt meters. So what are the watt meters required? So here KVA is not given. Okay, in the problem you can assume KVA as 1 kVA or 2 kVA. Okay, in problem it is decided to measure the parameter 230 volt bar 115 volt KVA transformer கொடுத்திருப்போம். அது வந்து 1 kVA இல்ல 2 kVA and you have to assume. So 1 kVA assume பண்ணினா you will get one answer. If you assume 2 kVA means you will get different answer. Okay. Next 8th question. 8th question இது நிறைய பேர் சால்வ் பண்ணிருக்கேன் ப்ராப்ளம். இது வந்து ஈஸின்றதுனால சால்வ் பண்ணியிருக்கேன். ஓகே, செகண்டரி டர்ன்ஸ், டிரான்ஸ்ஃபர்மேஷன் ரேஷியோ, வோல்டேஜ் பர் டர்ன்ஸ். ஸோ இதில் நிறைய பேர் வந்து இந்த 8th சப்டிவிஷனும் ஒரு 25% அட்டன் பண்ணியிருப்பீங்க. 8th கொஸ்டின். ஸோ 9th கொஸ்டின், அகெயின் 9th கொஸ்டின். ஸோ describe the method of calculating regulation and efficiency of a single phase transformer by open circuit test and short circuit test. So in this also ஒரு 95% வந்து you are stopped up to the parameter. You are not writing anything related to regulation or efficiency. So efficiency பத்தியும் எழுதல, regulation பத்தியும் எழுதல. ஒரு 5 பேர் எழுதிருப்போம் regulation, efficiency. So remaining members you have drawn that open circuit or short circuit diagram. அந்த ஓப்பன் சர்க்யூட்ல என்னென்ன பேராமீட்டர்லாம் கண்டுபிடிப்போம் அதை மட்டும் எழுதியிருக்கேன். ஷார்ட் சர்க்யூட்ல என்னென்ன பேராமீட்டர் கண்டுபிடிப்பாங்க அது மட்டும் எழுதியிருக்கேன். So you are not wrote anything related to regulation and efficiency. If you are not discussing anything related to regulation or efficiency, so you will get only 3.5 mark, 3.5 mark தான் உனக்கு கிடைக்கும் open circuitலயும் short circuitலயும். Okay, you have to write all the parameters. Open circuit na what are the parameters we are calculating? Not னு வருது பாரு, எல்லா நாட்டும் அங்க போட வேண்டியது. I naught, R naught, X naught, I mu, so I1, so everything will calculate from that test only, core loss component. So in short circuit test you will get the remaining parameters. Okay, so if you wrote only the open circuit and short circuit test you will get only 3.5, 7 marks தான் கிடைக்கும். So if you wrote anything related to regulation and efficiency means you will get closer to 5 marks, 4.5 வரும். ஓகே, இதெல்லாம் தான் ப்ராப்ளம்ஸ். உங்களோட ஆன்சர்ல வந்து உங்களுக்கு கொஸ்டின் you are not clear with the question also. You are not reading the question properly. So if you are reading the question properly only, then it's possible to write the answer for the particular question. If you are writing irrelevant answer means you won't get full mark. Okay, you may get partial mark. Okay, other than this, are you having any doubt? So already you know the marks, I think. You should get at least 15 mark out of 30. 30க்கு வந்து 15 marks அது வாங்கணும். ஓகேவா? So you know you will have some failures also. So that will reflect in your internal. That's it. So other than this, are you having any doubt related to CA? So shortly the answer key will be uploaded in the Google Classroom. You can go through the answer key also. So doubt will we'll move to the class. Class next topic. Okay. So next we'll discuss about the relationship between P2, PC, PM. So this we discussed in the so where we discussed in the power stages. So we'll have some power stages. So in that power stages we discussed about this topic. Okay. So can you tell what is by P2, what is by PC, what is PM? So in the power stages, we have given some notation. Okay. So what are the notations we have given? P in, we have given some notation. P2, we have given some notation. PC or PCU, PM, PG, TSH. So these are the some of the notations we have discussed in the power stages. Okay. So what is a P in means input power. Okay. That can be represented as a P1 also. So you can have a so P1 and P in will be almost the same only. Okay. So this is the input power. So you know the formula for the input power will what is the input power formula? So you'll have a root 3 VL IL cos phi L. So that is the input power equation. And next, what is by P2? So P2 is the rotor input. So this P2 is the rotor input. So what is the PM? Mechanical power generated. Okay. So what is the P out? P out is the total power generated. So here we are going to derive the expression for the P2, PC and PM. So P2 is the rotor input, PC is the copper loss, PM is the mechanical power. So what is the relationship between these three parameters? Okay. So already we have derived the formula also. Okay. So general power will give the expression as torque into omega. Torque into omega is given as the power equation. Okay. So this input power will be different. Okay. Omega you can give as 2 pi n by 60. 2 pi n by 60 we can give expression for omega. So for rotor input we are going to write the same formula as torque into omega s. Okay. Torque into omega s. So P2 is given as torque into 2 pi ns by 60. Okay. And mechanical power we can write PM is equal to torque into omega. So here in rotor input we are representing in terms of ns. So in the mechanical power we are representing in terms of running speed. So that is a small difference. So you know these parameters and all. P in. So you know what is my P in, and that is the input power. Then we have a stator. Then we'll have output will be P2. Okay, this and all we discussed. What is a P2 means? That is a rotor input or stator output. Rotor input or stator output. So the rotor input and stator output will be almost the same only. Okay. So the speed, what is the speed of the stator speed? That is ns. So in the P2 we are representing in terms of ns divided by 60. So at the mechanical power side, that is at the rotor output. At the rotor output, what is the PM? So PM will be the mechanical power developed in the rotor. So what is the PM formula? PM will be equal to P2 minus losses. What are the losses available in the rotor? Okay. So you will have the losses. So you can refer the mechanical power, mechanical parameter. Okay. So we have a the power stages. You can refer that. You will have a block diagram. Block diagram. You can refer that. You will have this formula. So mechanical power where rotor will have the speed n. So we'll have the PM mechanical power is equal to this value. And here this is not PC, P2. You can this consider as PC. Okay. So what is the PC? PC is the copper loss. How will you calculate the copper loss? So input minus output. So what is the input? Rotor input. And this is a rotor output. This is a rotor output. This is a rotor input. Okay. So can write the formula T into 2 pi ns divided by 60 minus T into 2 pi n by 60. Okay. And if you take the ratio between these two values, PC, this is the expression, and PM, this will be the expression. Okay. PC and P2. So P2 is this value, PC this value. So you substitute both the equation PC divided by P2, and you cancel the common terms. What are the cancel? If you have means, so this is 2 pi T into 2 pi by 60. So this 2 you can cancel, and then you will get the remaining terms in terms of N, Ns minus N divided by Ns. So copper loss to rotor input will be equal to slip. Copper loss to rotor input will be equal to slip. Okay. And next, you can write the PM equation. PM equation equal to rotor input minus rotor losses. Then here you are going to substitute this P2 into S. This value we are going to substitute. Okay. So in the place of PC. So PC we are substituting S into P2. And we can take the common terms P2. Then you will have 1 minus S into P2 equal to PM. Okay. And then if you write all the expression, P2 is to PC is to PM. Okay. Then you will get, suppose for this equation, P2 is to PC is to PM. So what is the P2 value? What is the P2? In terms of slip, you have to tell. In terms of slip, you have to tell the value. You substitute to all the values means. So what is the P2 means? P2 is to, you will get this final expression. You can see the board. So this is the final expression we are going to consider. P2 is to PM is to PCU. So thus we keep P2 as it is. PM, what is the value for PM? P2 into 1 minus S. Okay. And is to PC. This is SP2. And you divide this entire equation by P2 means, so you will get 1 is to 1 minus S is to S. So this is the relationship between so if I divide this equation by P2 means, you will get this relationship between P2, PM and PC. So these three terms are related to the slip value. All these three terms related to the slip value. So what is the final expression? You will get to 1 is to 1 minus S is to S. That will be equal to P2 is to PM is to PCU. Are you clear? So this is a relationship between the rotor input, mechanical power, copper loss. Okay, so from the basic equation, so we are obtaining all the values. Okay, so where you have to put NS, where you have to mention N. So if the parameters are related to stator, so you can mention as synchronous speed. If the parameters are related to rotor, you have to mention in terms of running speed. So that you have to remember. And for this expression, you can refer the power stages. So from the what are the notations you are using in the power stages? So same we are used here also. Okay, and we are obtained the expression as what is the relationship between these three parameters? Rotor output, sorry, rotor input, mechanical power, and copper loss. And you have to remember this final expression. So this will be used in the formulas. While you are solving the problems, you require some formulas, no? So there you can use this relationship. Okay. Are you clear up to this? Shall we move to the problem? So in the previous class, what are the things we discussed in the previous class? Means we discussed the power stages, and what are the expressions related to the power stage we discussed, and then we discussed about the slip torque characteristics. So what are the regions available in the slip torque characteristics? So before entering the problems, we will refresh what are the topics we discussed in the previous class. So what are the regions generally available in the slip torque characteristics? தம்பி நிறைய பேர் 80 பேருக்கு மதியம் எக்ஸாமே கிடையாது. ஓகேவா? அதனால இவ்வளவு நாள் தான் வந்து கிளாஸ் நடக்கும்போது படிச்சேன் கிச்சன் ஏதோ கதையெல்லாம் விட்டீங்க. ஸோ இன்னைக்கு லேட்டரல் என்ட்ரி ஸ்டூடெண்ட் தவிர மற்ற ஸ்டூடெண்ட்டுக்கு யாருக்குமே எக்ஸாம் கிடையாது மதியம். சரியா? அதனால ஆன்சர் சொல்லுங்க. வாட் ஆர் த ரீஜியன்ஸ் அவைலபிள் இன் த ஸ்லிப் டார்க் கேரக்டரிஸ்டிக்ஸ்? சொல்லிட்டீங்கன்னா அடுத்து ப்ராப்ளத்துக்கு போயிடலாம். ஹரிஹரன், ட்ரிபிள் ஒன், ட்ரிபிள் ஒன் இல்லையாப்பா? 110, இந்த ப்ரீவியஸ் கிளாஸ்ல வந்து நம்ம டிஸ்கஸ் பண்ணோம் இல்லையா? நீ நோட்டை கூட பார்த்து சொல்லலாம், ஒன்றும் பிரச்சனை கிடையாது. இந்த ஸ்லிப் டார்க் கேரக்டரிஸ்டிக்ஸ்ல என்னென்ன ரீஜியன்ஸ்லாம் இருக்கு? வாட் ஆர் த ரீஜியன்ஸ் அவைலபிள் இன் த ஸ்லிப் டார்க் கேரக்டரிஸ்டிக்ஸ்? So anybody know means you can post in the chat box. ஹரிஹரன் 110, 111, ஹரிநேஷ், ரெண்டு பேர்ல யாராவது சொல்லுப்பா ஆன்சர். எஸ்ஆர்னா அதுக்கப்புறம் ஆளே காணும். அஸ்வின், அஸ்வின் இருக்கானா?
சார் ஸ்டேபிள் அன்ஸ்டேபிள்
சொல்லுடா, நல்லா மைக் ஆன் பண்ணி சொல்லுடா. ஏதோ வந்து உடனே ஏன் கட் பண்ணிக்கிறேன்? புரியல. ஸ்டேபிள்
அன்ஸ்டேபிள் நார்மல்.
ஸ்டேபிள் அன்ஸ்டேபிள் நார்மல். ரெஃபர் த நெட். ஓகேவா? நெட் ரெஃபர் பண்ணி சொல்லிட்டு அதானே? ஓகே ஓகே, தேங்க்யூ. ஓகே. So in the slip torque characteristics, we discussed about three regions: motoring region, generating region, and braking region. So based on the slip value, slip is negative, slip is positive value. So slip, you will have three values: slip range from 0 to 1, slip negative, slip greater than 1. So these are the three modes of slip torque characteristics. So motoring region will have the slip value from 0 to 1. So in the generating region, we'll have the slip value from above 1. So in the braking region, we'll get to the negative slip. So this we discussed as a overview. Then we concentrated on the motoring region. So in the motoring region, so we'll have four cases. So torque equal to 0, slip equal to 0. So low slip region, maximum torque, high slip region. So இதான் நம்ம டிஸ்கஸ் பண்ணோம். ஓகேவா? So at origin we'll have t equal to 0, s equal to 0. So in the low slip region, so what will happen? So both will be almost linear. Okay, torque will be directly proportional to slip. This is so during the low slip region. So maximum torque. So what is the condition for maximum torque? When you will get maximum torque? So if the rotor resistance equal to rotor reactance. Okay, so we'll get to the maximum torque. Then we'll have a high slip region. So in the high slip region, so what will happen? The torque will be inversely proportional to the slip. Okay, so these are the four regions available in the torque slip characteristics in the motoring region. As a overview, you can tell as a motoring, generation, and braking as an overview. And with respect to our case, that is induction motor, so we'll have the 4 regions of operation. So RGN, that is the ideal condition. Then we'll have a low slip region, maximum region, and high slip region. Okay, other than stable and unstable, okay, yeah, low slip region you will call as a stable region. So high slip region you will call as an unstable region. Okay, so அதுதான் வந்து நார்மல் அப்படின்னு நார்மல் ஸ்டேபிள் அன்ஸ்டேபிள்னு சொல்லி அறிஞர்னு சொல்லியிருக்காப்புல. ஓகேங்களா? ஸோ ஓகே, ஸோ நெக்ஸ்ட் வில் மூவ் டு த ப்ராப்ளம் ரிலேட்டட் டு வாட் ஆர் த டாபிக்ஸ் வி டிஸ்கஸ்டு. ஓகே, ஸோ யூ டேக் த ஃபர்ஸ்ட் ப்ராப்ளம். So active power input to a 415 volt 50 hertz 6 pole 3 phase induction motor running at 970 rpm is 41 kilowatt. So the input power factor is 0.9. The stator losses amount to 1.1 kilowatt and the mechanical losses total 1.2 kilowatt. Find line current, slip, copper loss, mechanical power output, and efficiency. So you write the given data. So in module 2, you are having only one topic. Okay, starting methods of 3-phase induction motor. So we will solve some problems. Today and tomorrow we will solve problems. Okay. So Wednesday morning we will discuss about the starters of 3-phase induction motor. Okay, for the complete we will almost module 2 is going to over. Okay. So what are the parameters given? So line voltage is equal to 415 volt. The frequency 50 hertz. So number of poles is 6. So speed is equal to, so n is equal to 970 rpm. And so power input. So power input equal to 41 kilowatt. And the cos phi is equal to 0.9. And the stator losses 1.1 kilowatt. Mechanical losses 1.2 kilowatt. So these are the parameters given. And you write the parameters and you take the first subdivision. So what is the first subdivision? You have to suppose to calculate the line current. And it's possible to tell the formula for line current. So one by one we can solve. So anyone know the formula for line current? Every calculate பண்ணுவா. First subdivision you are supposed to calculate line current. So what is the formula for line current? We call that is IL. You are supposed to calculate IL value. So if you know the formula means you try to solve. Okay. So what is the formula for how to calculate the line current? யூ கேன் ரெஃபர் நோட்ஸ் எழுது, நோட்ஸ் எழுதினா தான் ப்ராப்ளம் சால்வ் பண்ண முடியும். ஸோ இந்த செமஸ்டர் எக்ஸாம் உனக்கு வந்து ஆஃப்லைனில் கூட இருக்கலாம், ஆன்லைன் நினச்சிட்டு இருக்காத. ஸோ நான் இப்போ நவம்பரில் காலேஜ் ஓப்பன் ஆச்சுன்னா யூ ஹாவ் எக்ஸாம்ஸ் த்ரூ ஆஃப்லைன் மோட் ஆல்சோ. யூ ஷுட் பி ரெடி ஃபார் எவ்ரி திங். ஓகே, ஸோ வாட் இஸ் த வேல்யூ ஃபார் லைன் கரண்ட்? I will write the formula. Okay, power in is equal to root 3 VL IL cos phi L. So power in is given. So root 3. So line voltage given. Cos phi also given. So what is the value for IL? Cos phi தான் 0.9 போட்டுக்கேடா. Cos phi. So given dataவில் இருக்கு பாரு 0.9. போர்டு பாரு. So the problem itself it's given as power factor is 0.9. இதை கால்குலேட் பண்றது இவ்வளவு நேரமாடா? மொபைல்ல ரூட் 3 வரலையா? அபிராமி 102. $57.04. Any other answer? Okay. 64.6. Okay. And the answer ஒன்று accept பண்ணிக்கலாம். So 63.3771 amps. So அபிராமி அஸ்வின் தவிர மற்றவங்க என்ன பண்றீங்கன்னு தெரியல. ஓகே, ஸோ யூ செக் த ஆன்சர் இஃப் இட் ஷுட் பி க்ளோசர் டு 64. ஸோ 57 கொஞ்சம் செக் பண்ணிடுங்க என்ன ப்ராப்ளம்ட்டு. ஓகே, நெக்ஸ்ட் யூ மூவ் டு த செகண்ட் சப்டிவிஷன். What is the second subdivision? You are supposed to calculate the slip. So how to calculate the slip? Slip is equal to ns minus n divided by ns into 100. So n value is already given in the problem. N is equal to 970 rpm. Okay, then you are supposed to calculate the ns. What is the ns? 120 f by t. Okay, so frequency is 50 Hz, pole is 6. So 120 into 50 divided by 6. So you will get almost 1000 rpm. And then you tell the value for slip. Okay, Venkatesh. You continue with the second subdivision. So what is the value for slip? So if the synchronous speed is not given in the problem, means the calculator. Okay, or already you know that. So instead of calculating, so almost frequency will be always 50 Hz only. So 2 pole is given means you choose 3000 rpm as a synchronous speed. 4 pole means 1500. 6 pole means 1000. So like this you can also have this constant value and you can substitute here in the place of ns based on number of volts. Okay. 3%. Okay. Abhirami, Janini, Jivita. Okay. So I mentioned as a 3%. Okay. So slip is equal to 3%. So what about third subdivision? So third subdivision, you are supposed to calculate copper loss. Okay. So how to calculate? What is the notation for copper loss? எப்படி copper loss calculate பண்ணீங்க? So what is the formula for copper loss? I square R. Okay. I square R is the R 3 phase na 3 I square R. So in terms of slip means you will have different formula. So here how to calculate the copper loss? Copper loss means you are supposed to calculate PC. So PC then calculate பண்ணும். PC will call this as a copper loss. Then what is the formula for PC? So PC equal to P2 minus PM. So what is the P2? So P2 you will call this as a stator output or rotor input. Okay. And PM will call this as a mechanical power. Okay. So this is the, if you are having a rotor means, so the input to the rotor is P2. The output of the rotor is PM. So the loss occur here is a PC. Okay. So PC equal to P2 minus PM. Okay. Then how to calculate the P2 and PM? You have to discuss in terms of slip. Other than the equation derive பண்ணிருப்போம். So P2 equal to is to, so PC is to PM is equal to 1 is to S is to 1 minus S. So the மாதிரி expression வந்து derive பண்ணிருப்போம். You can use this formula to calculate the unknown parameter. Okay, you know the slip value and you can calculate this PC value. Okay. So P2, what is the formula for P2? So you can have P in minus, here there some losses are given. Here you see stator loss is given, mechanical loss is given. Okay. If you know the stator loss and you know the input power, okay, then you can calculate the P2. So this is the stator loss. So here we are having the 3 parameter. So at least if you know the 2 parameters, so you can calculate the another parameter. So for that only we are going for this P2. Okay. So P2 can calculate this P in divided by so minus stator losses. Okay. And from this expression you can have P2 by PC equal to 1 by S. And if you calculated P2 means you know the slip value, you can calculate the PC. Okay. So for that only we are calculating this P2. Okay. You can have this ratio P2 by PC equal to 1 by S. You know already calculate the slip value. If you found the P2 value means you can calculate the PC. So what is the P2 value? Then now you tell the P2 value. So this P in we already have the value. P in is equal to 41 kilowatt. So stator loss is 1.1 kilowatt. Then you know the P2. What is the P2 value? 39.9 kilowatt. Okay. So P2 is equal to 39.9 kilowatt. Okay. Then you tell the value for PC. And here you should not substitute. What is the value here? You will substitute slip value. You substitute 3% or 0.03. What is the value you will substitute here? Here it is a percentage slip or slip. What is the difference between slip and percentage slip? If you multiply by 100 means you will get percentage slip. And what is the normal slip? already we will know that the slip value will be range from 1 to 0. அப்படிலாம் சொல்லியிருப்போம். So what is the value here? You substitute, either you will substitute fractional slip or which value here you will substitute? Ashwin, what is the 33.3? என்ன value அது? P2 ஆ? You check that answer. 33 வராது. So it's 4 இல்ல டைரக்டா அப்படியே மைனஸ் பண்ண வேண்டியதானே. 41 minus 1.1 kilowatt. 41 minus 1.1 kilowatt. அதான் நீ மைனஸ் பண்ண போறான். Then you will get 39 point. Dinesh Kumar 1.197. அதுதான் இங்க கேக்குறேன். What is the value here you substitute here? Either you substitute 0.03 or 3%. You have to substitute 0.03 only. So here you have to substitute as a fractional slip only. 3 in substitute பண்ண கூடாது. Here. So you have to substitute 0.03. So 1.197 kilowatt. Okay. So here what is the value for PC means 1.197 kilowatt. And what about the, are you clear up to this? Any doubt இருக்கா இல்ல பாரு. So PC equal to 0.03 into P2. So P2 வந்து 39.9 into 10 power 3. So அதான் கிலோவாட்னு சொல்லிருக்கோம். Yeah, so you get 1.197 kilowatt. Okay. So next subdivision, fourth subdivision. So you are supposed to calculate mechanical power output and efficiency. So mechanical power output. So we'll have two notations in mechanical. Okay. So this is a mechanical power. This is the output power, mechanical output power. So one will be gross, another will be net. That is a shaft. Okay. You are supposed to calculate this both the value, because we are next subdivision we are going to calculate efficiency. So efficiency என்ன வரும்? P out divided by P in into 100. Okay. So what is the mechanical power output? What is the formula for mechanical power output? Again you can go to this relation. So here you know all this value. You know P2 value, you know PC value. So you don't know the PM value. Okay. You can have any relationship between this. Okay. If you are supposed to calculate PM. So you can choose like this: PC divided by PM equal to S into 1 minus S. So tell the value for PM. எல்லா வேல்யூமே உங்களுக்கு தெரியும், ஸ்லிப் வேல்யூ தெரியும், பிசி வேல்யூ தெரியும். You are supposed to tell only PM value. You know the slip value, so you know the PC value, PC calculate பண்ணியாச்சு. You need to supposed to tell PM. So PM 38.703 kilowatt. Okay, Ashwin. Okay. Abhiram Jivita, okay. So next you calculate the P out. So what is the formula for P out? What is the formula for P out? So if you subtract the mechanical losses from the PM value, what is the formula for P out means? So P out is equal to PM minus mechanical loss. So calculate the PM value, and you know the mechanical loss is 1.2 kilowatt. Then you can calculate the P out. So 38.703 minus 1.2, and you will get the P out value. So what is the value for P out? $37.503. Okay. Then you calculate the efficiency. Okay. You sure? Okay, correct. So efficiency will be, so P out 37.503. So divided by P in. So P in is 41. So you get the 97.470. Okay. The problem is there doubt. Any doubt in this problem?
Sir, third solution more than 3%, sir.
It's a similar problem we won't solve. Okay. So each and every problem will have a different type. Okay. Okay, shall we move to the next problem? Are you having any doubt in this first problem? So not having means we'll move to the next problem.
Sir, copper loss மட்டும் 3%, sir.
Napa Ashwin sollu.
Copper loss மட்டும் 3% நடத்துங்க, sir.
Copper loss form. 1 second. காப்பர் லாஸ் ஃபார்முலா இங்க தனியா யூஸ் பண்ண தேவையில்லை. இப்போ காப்பர் லாஸ் ஃபார்முலா வந்து நம்ம வந்து ஈக்குவலன்ட் சர்க்யூட் டெரைவ் பண்ணும்போது டெரைவ் பண்ணிப்போம் பாரு. 3i2 ஸ்கொயர் i dash ஸ்கொயர்ட் R2 டிவைடட் பை S, அதான் வந்து காப்பர் லாஸ் ஃபார்முலா. ஓகே, 3i ஸ்கொயர்ட் Rன்னு இருக்கும் ஜெனரல் ஃபார்முலா. ஸோ சிங்கிள் ஃபேஸில் I ஸ்கொயர் R. ஸோ அதான் ஃபார்முலா. த்ரீ ஃபேஸ் வரும்போது என்ன பண்ணுவோம், நம்ம I2 அப்படின்னு ஒரு யூஸ் பண்ணுவோம் ரோட்டாருக்கு. அதனால I2 டேஷ்னு வந்துடும். ஓகேவா, 3I2 டேஷ் ஸ்கொயர் இன்டூ R2 டிவைட் பை S. அதான் வந்து காப்பர் லாஸ் ஃபார்முலா. ஓகேவா?
எஸ் சார். ஓகே சார்.
அந்த ஃபார்முலா இங்க யூஸ் பண்ண மாட்டோம் நம்ம மேக்ஸிமம். ஏன்னா so we are going to use that relationship. ஓகேவா, அந்த P2 PC PM ரிலேஷன்ஷிப் வச்சு காப்பர் லாஸ் கண்டுபிடிச்சிடலாம். சரியா?
எஸ் சார்.
Okay. So you take the next problem. So a three phase 400 volt 50 hertz 4 pole induction motor has a star connected stator. So you copy the problem and you write the given data. Then you calculate the synchronous speed, slip. எந்த சப்டிவிஷன் இது தெரியுமா அது வரைக்கும் கால்குலேட் பண்ணு. So I will tell the remaining subdivision. So write a three phase system, voltage equal to 400 volt, frequency 50 hertz, number of poles 4. So the rotor resistance is 0.1 ohm and the reactance is 1, and full load speed N is equal to 1440. And find the synchronous speed, slip, rotor EMF per phase. The torque near spelling mistake. Torque developed by the motor on full load condition. So you calculate one by one. So what is the value calculated? Ns equal to 1500. So write the given data, we'll continue with the problem. So Ns slip equal to 4. Okay, correct. So these are the data given. VL equal to 400 volt, frequency equal to 50 hertz. So pole is equal to 4. So R2 is equal to 0.1 ohm. So X2 equal to 1 ohm. So N is equal to 1440 RPM. So first subdivision and you calculated, I think. Okay. So synchronous speed you calculated 120 F by P. So that is 124 divided by 120 into 50 divided by 4. So you calculate as 1500 RPM. Then you calculate the slip. Percentage slip is equal to Ns minus N divided by Ns into 100. So what is the slip value? 4%. So what is the third subdivision? You are supposed to calculate the rotor EMF per phase. Okay. So what is the rotor EMF? You are supposed to calculate E2. You are supposed to calculate the E2 value. Suppose if we consider, so E1 by E2. So this is equal to, this is stator turns divided by rotor turns. So you will have some formula. If you are, so K, you are supposed to find what is the ratio between the stator to rotor turns. Okay. And this you are supposed to calculate. So what are the voltages here we are having? So we are having this voltage as a 400 volt. So this is the input voltage. We can consider this as a E1. Okay. You can consider E1. So what is the connection on the rotor circuit? So it is almost similar to star connected and it is short circuited. So that is a line voltage. You are supposed to calculate the phase voltage. So E1 phase. So E1 phase 400 divided by root 3. First we calculate this. Here we are going to discuss everything in terms of per phase only. So here rotor EMF per phase. Okay. So we are converting this E1 value in terms of per phase. Okay. And here you will get 230.94. And here this ratio is not given. So in this problem, okay, 230.94. Okay. So this is stator turns to rotor turns will be generally be given in the problem. Suppose in this problem it is not given. Then what you can do means you can consider this, you can assume. So let stator to rotor turns ratio will be some 1.75. And you substitute, you consider this value. You have to assume. So stator to rotor turns ratio will be 1.75. Suppose if it is given in the problem means you can take that value. If it is not given in the problem means you can assume some value. Okay, within that range. And what will be the value of generally K value means? So it will be generally vary from 0 to 3 like that. Okay, and I am choosing 1.75. So from this expression, so E1 by E2 is equal to 1.75. From this you calculate the E2 value. So this is not given in the problem. So stator to rotor turns ratio is not given the problem. We are assuming this value. And E1 by E2 is equal to 1.75. You tell the value for E2. $131. You have to remember this. That value were assumed only. It is not given in the problem. In some problem, directly the turns ratio will be given. Okay. So in this problem, it is not given. So we are assuming that value. Sorry, clear up to this? So next, last subdivision, torque developed during full load condition. So we discussed about the torque equation. Okay. So already we discussed about the torque equation. So what is the full load condition? What is the formula we are supposed to use? What are the torque we discussed? We discussed about the general torque equation. So we discussed about the starting torque equation. We discussed about maximum torque. So next we discussed about running torque. So which equation here we have to consider? Torque under full load condition means in the torque equation consider pannom. Are you having any idea? General torque equation will have, starting torque will have maximum torque. So we'll have a running torque. So all these equation will be somewhat slightly different. Okay. So if it is full load means full load either slip will be present or absent during full load condition. During full load condition, slip will be present or absent. When the slip will be absent, when the slip will be 0. Ideal condition. Okay, ideal means starting condition. Ideal means you are trying to start. Okay, good. Abhirami, okay. So during running condition means you can use this equation. You see this equation, it should have slip K S E2 squared R2 divided by R2 squared plus S X2 whole squared. So இது மாதிரி derive பண்ணி போணும் by equation. ஓகேவா? So this is torque equation during full load or running condition. Okay. So during a running condition, you will have this general slip equation like this. Okay. And you know the value for K. What is the value for K? So K is equal to 3 divided by 2 pi small ns. So what is the difference between capital Ns and small ns? It is RPM. This is RPS. Okay. Revolution per minute, revolution per second. Okay. So this is the difference between the capital Ns and small ns. Okay. Then what is the formula for this will be? So ns divided by 60. So we will give this value, small ns. So you try to solve and tell the answer for torque. So in use pandrathu vandu you have to remember this in constant you will use only small ns. Okay. So this is the difference between the small and the capital ns. Okay. So ns will be in terms of rpm, that is a synchronous speed, and this is the synchronous speed in terms of seconds. Okay. So capital ns divided by 60 will give the small ns value. So tell the answer for torque. K is equal to Ashwin, once again you check. Once again check the answer. 0.019 torque. Once again you have to check. எல்லாமே தப்பு தான் answer. So E1. So இந்த E2 வேல்யூல இங்க சப்ஸ்டிட் பண்ணீங்களான்னு பாருங்க. 131.9 அதுதான் அங்க E2 ல சப்ஸ்டிட் பண்ணும். 131. So here what is the torque na? Torque equal to 3 divided by 2 into pi into ns value. So ns value வந்து 25 வருது. 25 into what is the slip value? So slip வந்து 4%. So 0.04 into 131.965 whole square. So what is the R2 value? 0.1. So divided by 0.1 squared into 0.04 into 1 whole square. So in the equation full substitute பண்ணிருக்கீங்க பாருங்க. Then you tell the answer. So what is the torque equation? Torque கூட ஆன்சர் என்னப்பா? Six 6.5 into 10 power 3. Any other answer? Into 10 power 3 ல எப்படி வருதுன்னு தெரியல, செக் பண்ணுங்க கொஞ்சம். ஸோ பை வேல்யூ வந்து 3.14 போடணும். பை வேல்யூ இந்த பை வேல்யூ வந்து 3.14 போட்டுருங்க. 3.14 180 போட்டுறாதீங்க. 43500. வேற ஏதாவது ஆன்சர் இருக்கா? எனி அதர் ஆன்சர்? எல்லாமே அதிகமா வருது. செக் ஒன்ஸ் அகைன் த ஆன்சர். Two 0787. எனி அதர் ஆன்சர்? இந்த எல்லா ஆன்சருமே தப்பா இருக்குமா தெரியுது. So anybody is getting 114 point something? One 1. So kilowatt இங்க சப்ஸ்டிட் பண்ணிருக்கீங்களா? Why it is how you are getting into 10 power 3 and all? Four to 600. Anybody is getting 114 Newton meter? One 114.688. Anybody is getting? So why all are getting different answer? I don't know. 6.5 into 10 power minus 3, 43,500, 20787, 15, 1,50,115, 4 to 600. எப்படி எல்லாருக்கும் different answer வருதுன்னு தெரியல. We have same value only. So you check once again, are you getting this value 114.6? So no one is getting this answer means I will check once again the answer. So if any deviation means I will tell. So anybody is getting 114? No one is getting? Okay, 114. So Janini Preeti. Formula read out பண்ணமா torque equal to K into slip E2 squared. Okay. So torque equal to K slip S E2 squared R2 divided by R2 squared plus S H2 whole squared. Very clear? Abhirami? Ks E2 squared R2 divided by R2 squared plus S H2 whole squared. So in the place of K, so you substitute 3 divided by 2 pi small ns. Okay. So ns தான் ஏற்கனவே சொல்லியிருக்கேன். Small ns equal to capital Ns divided by 60. Okay. And if substitute means you will get this value. So 3 divided by 2 into 3.14 into 25. So you will get that value from small ns, you will get 25. So here you are substituting slip value 0.04. So E2 squared 131.965 whole squared into R2 on the 0.1. So divided by R2 squared 0.1 squared into 0.04 into 1. So it's on the whole squared. So 0.1 into 1 whole squared. Okay, you should get around 114 point something. So other than Janini, anybody getting 114? Okay. Okay, Rupan. Okay. So that's all about the today class. Okay. So tomorrow also we are going to solve the problem only. So in the question paper we will have both the theory as well as the problem. So we'll solve some more problems on the tomorrow class. Okay. So I will give general instruction. So related to the CA2. Okay. So CA1 is going to complete for all the courses by tomorrow, I think. So today you will have EVS and tomorrow you will have consumer electronics. So in this EVS only 7 students are attending. In the case of consumer electronics, we will have only 33 students. So remaining students are almost free in the afternoon session, I think. Okay. So no other work will be, we are not having. From October 12, you will have CA2. Okay, because CA1 is postponed for 3 times. So almost 10 days it is postponed. So CA2 will occur as per the schedule. So October 12 you will have the CA2. So before that, already all the faculty have given assignment 1, I think. Okay. So you try to complete the assignment 1. If you are not submitted means, still if you are not completed means you try to complete it by today afternoon or tomorrow. So and next you will have a unit test before October 12 for all the courses. So that the schedule will be prepared and it will be circulated in your group. Okay. So for all the courses you will have the unit test 1. What is the unit test 1 portion means? Module 2 first half. Okay. So as per the team concern, so before induction motor, சார் எடுத்திருப்பாங்க, நாகராஜ் சார் எது வரைக்கும் எடுத்திருக்காங்களோ இண்டக்ஷன் மோட்டருக்கு முன்னாடி என்னென்ன டாபிக் இருக்கோ மாடியூல் 2ல அது எல்லாமே வந்து யூனிட் டெஸ்ட் 1க்கு வரும். That is a module 1 first half. Okay, that is we will have a 3-phase transformer, I think. So that will be scheduled before October 12. Within October 12, you are supposed to complete the unit test for all the courses. So how the CA1 is conducted, similarly the unit test will also be conducted via Google Classroom. So schedule will be released soon. So the question paper will be displayed similar to CA test 1, and you have to write the similar procedure like CA1. So assignment you can submit by writing the content in the A4 sheet, and you can scan, and by writing your roll number and name, you can upload in the in that concern course assignment page. Okay, but the unit test will be monitored and it will be conducted so before October 12. So you try to prepare for the module 1 first half. So it will be convenient to write the unit test 1. So this is the general instruction. So soon the tutors will share the schedule in your WhatsApp group. So that's all from my side. So thank you. Okay, tomorrow afternoon we'll solve only the problem. Okay, so you have your calculator and you have your notes. Okay, so that only you can able to solve more problems. If you are quickly giving the answer, means we'll go for the next problems. Okay, so that we try to complete as much as possible the number of problems. So Wednesday morning we'll have a theory class. Okay, thank you.